Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss three-dimensional geometry. In the previous class, we have discussed vector algebra. In that chapter, we have discussed the concepts of cross product of two vectors or vector product of two vectors. And we have completed exercise 10.4 also. Okay, my children, I hope you have understood the concepts of the exercise 10.4 and sums, the sums in the exercise 10.4 well. Haven't you, my dear children? Right. Now come to this exercise 11.1 concepts. We are going to discuss the concepts of exercise 11.1. Okay, my children. Right. See the first point, direction cosines and direction ratios of a line. We have already discussed in the previous chapter in the vector algebra also a directed line. A directed line is nothing but a vector. Okay, my children. So let us recall that if a directed line L passes through the origin, makes angles alpha, beta, and gamma with x, y, and z axis respectively, called direction angles. Okay, my children. Do you remember these points? Then cosine of these angles, namely cos alpha, cos beta, and cos gamma, are called direction cosines. In the short form, small letter d dot c dot s. Okay, my children. This is a short form of direction cosines of the directed line. Okay, my children, we have already discussed direction cosines of a vector, direction ratios of a vector. Okay, my children, a directed line is nothing but is called here a vector. Okay, my children, if we reverse the direction of L, then the direction angles are replaced by their supplements, that is pi minus alpha, pi minus beta, and pi minus gamma. Thus, the signs of the direction cosines are reversed. Okay, my children. Then direction cosine of this line with which is making pi minus alpha, pi minus beta, and pi minus gamma with x, y, and z axis, or minus cos alpha, minus cos beta, and minus cos gamma. Okay, my children, understood these points, right? Note that a given line in space can be extended in two opposite directions, and so it has two sets of direction cosines. Okay, my children, we can extend that line in two opposite directions. So it has two direction cosines. Okay, my children. In order to have a unique set of direction cosines for a given line in space, we must take the given line as a directed line. Okay, my children, to take a unique set of direction cosines, we take a directed line, not a line. Understood the difference between a line and a directed line, my children? Lines. These unique cosines are denoted by small letter L, comma, small letter M, and small letter N. Okay, my dear children, L, M, N denotes a unique set of direction cosines of a directed line. Okay, my dear children, remark, if the given line in a space does not pass through the origin, then what should we do in this case? Then in order to find its direction cosines, we draw a line through the origin and parallel to the given line. Okay, my dear children. Then automatically we get like this only. See this figure, my dear children. Observe this figure. X-axis, here Y-axis and Z-axis. This is a directed line. OL is a directed line. This directed line is making an angle of alpha with the positive x-axis in the positive direction, means in the counterclockwise direction, and beta is the angle made by this directed line OL with the positive y-axis in the counterclockwise direction, and similarly Z with the z-axis here also in the counterclockwise direction in the positive z-axis is gamma. These are the angles made by this directed line in the space. In case if a line is not passing through the origin, in that case we have to draw a line passing through the origin which is parallel to the given line. Then automatically again we get the same kind of figure, same kind of structure. Okay, my children, understood this point? Right. Now, take one of the directed lines from the origin and find its direction cosines, as two parallel lines have the same set of direction cosines. Okay, my children, that is why if a line is not passing through origin, in that case we have to draw a line passing through origin, and then we find direction angles, and with the help of direction angles we find the direction cosines of the line. Understood this point, my children? Right. Any three numbers which are proportional to the direction cosines of a line are called direction ratios. It is a short form of the word direction ratios. Small letter D dot small letter R dot S, small letter S, DRs. These are also called DRs, stands for direction ratios of a line. Okay, my children. So any three numbers which are proportional to the direction cosines of a line are called direction ratios of the line. Understood this point, my children? Direction cosines of a line is unique, but direction ratios of a line are infinitely many. Okay, my children. If L, M, N are direction cosines, means DCs, and small letter A, small letter B, small letter C are direction ratios, that is DRs of a line, then A is equal to lambda L, B is equal to lambda M, and C is equal to lambda N. For any non-zero, lambda belongs to R. Understood this point, my children? This is the relation between direction cosines and direction ratios of a line. Remember this relation between direction cosines and direction ratios of a line. Okay, my children? Right. Note, some authors also call direction ratios as direction numbers. Okay, my children? Both words denote the same. Direction ratios or direction numbers, both denote the same. Don't be confused among these two words. Okay, my children, understood this point? Right. So come to the second point. Let A, B, C be direction ratios of a line, and let L, M, N be the direction cosines, that means DCs of the line. Then L is equal to plus or minus A by square root of A square plus B square plus C square, M is equal to plus or minus B by square root of A square plus B square plus C square, N is equal to plus or minus C by root of A square plus B square plus C square. This is the relation between direction cosines and direction ratios of a line. Okay, my children, remember these points as a formula. Memorize these points as a formula. Okay, my children. Right. Now come to the next point, third point, relation between the direction cosines of a line. Okay, my children. Here in this point we are going to discuss the relation between direction cosines of a line. Okay, my children. Right. If L, M, N are direction cosines of a line L, then L square plus M square plus N square is equal to 1. This is also important result. Okay, my children. This result also can be used as a formula. Okay, my children. So memorize this result also. L square plus M square plus N square is equal to 1 is said to be the relation between the direction cosines of a line. Okay, my children. Right. Now come to the fourth point. Direction ratios of a line segment joining Px1, comma y1, comma z1 and Qx2, comma y2, comma z2 or direction ratios of line segment PQ is equal to ordered triplet x2 comma x2 minus x1 comma y2 minus y1 comma z2 minus z1. These three numbers are said to be direction ratios of the line segment joining the points P and Q, where P is equal to x1 comma y1 comma z1 and Q is equal to x2 comma y2 comma z2. This point also can be used as a formula. Okay, my children. So remember this point also as a formula. Okay, my children. Right. Now come to the fifth point. The last point of this exercise. The last concept of this exercise. Direction cosines of a line segment joining Px1, comma y1, comma z1 and Qx2, comma y2, comma z2 are DCs of line segment PQ is equal to ordered triplet x2 minus x1 by PQ, comma y2 minus y1 by PQ, comma z2 minus z1 by PQ, where PQ is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is nothing but distance between the 2 points P and Q. Do you remember this point, my children? Right. So remember this point also as a formula. Memorize this point also as a formula. Okay, my children? Right. The concepts of this exercise 11.1 were completed. Okay, my children. Now let us start the problems in the exercise 11.1. Page number 467 in the textbook. Okay, my children. Right. See the question number 1. First question in the exercise. If a line makes angles 90 degrees, 135 degrees, 45 degrees with the x, y and z axis respectively, find its direction cosines. Understood this point, my children? In this question, direction angles are given. That is 90 degrees, 135 degrees and 45 degrees. Direction angles are given. We have to find direction cosines. Okay, my children? Right. Let alpha is equal to 90 degrees, beta is equal to 135 degrees and gamma is equal to 45 degrees are the angles made by a line with x, y and z axis respectively. Understood this point, my children? We have assumed that alpha is equal to 90 degrees, beta is equal to 135 degrees and gamma is equal to 45 degrees. These three angles are the angles made by the line with x, y and z axis respectively. Okay, my children? Therefore, direction cosines DCs of the line is equal to plus or minus ordered triplet cos alpha, cos beta, cos gamma. Okay, my children? This is the formula to find the direction cosines of a line if the direction angles are given. Okay, my children? Right. That is equal to plus or minus cos, what is alpha here? 90 degrees. Cos, what is the value of beta? 135 degrees. Cos gamma, cos 45 degrees. Okay, my children? Understood this step? Right. What is the cos 90 degrees value? Cos 90 degrees value is 0. Yes or no, my children? So cos 90 degrees value is 0. Cos 135 degrees value is minus 1 by root 2. Cos 45 degrees value is 1 by root 2. So plus or minus ordered triplet 0 comma minus 1 by root 2 comma 1 by root 2. This is direction cosines of the line. Understood, my dear children? Right. Now come to the next question. Question number 2 in the exercise. Find the direction cosines of a line which makes equal angles with coordinate axis. Understood this question, my dear children? Here a line is making with coordinate axis equally. Okay, my dear children, the angles are equal. Okay, my dear children? Right. So let the angle made by a line with each of the coordinate axis is alpha. Let us consider the angle made by the line with each of the coordinate axis is alpha. Then what is the relation between the direction cosines of a line? Yes, cos square alpha plus cos square alpha plus cos square alpha is equal to 1. Yes or no, my children? S square plus m square plus n square is equal to 1. Where L is equal to cos alpha, m is equal to cos beta, and n is equal to cos gamma. Direction cosines. Yes or no, my children? But here alpha, beta, gamma all are equal. Understood this point, my children? Right. This implies what we get? 3 cos square alpha is equal to 1. Yes or no, my children? This implies cos square alpha is equal to 1 by 3. Cos square alpha is equal to 1 by 3. This implies cos alpha is equal to plus or minus 1 by root 3. Understood this step, my children? Right. Therefore, direction cosines, that is DCs of the line plus or minus 1 by root 3 comma 1 by root 3 comma 1 by root 3. This ordered triplet plus or minus of ordered triplet 1 by root 3 comma 1 by root 3 comma 1 by root 3 is the direction cosines of the line. Understood, my dear children? Right. Now come to the question number 3. Next question. Third question in the exercise. If a line has the direction ratios minus 18, comma 12, comma minus 4, then what are its direction cosines? Understood this question, my dear children? Right. Here direction ratios of a line are given. We have to find direction cosines of the line. Okay, my dear children. So let us write the direction ratios of a line. Small letter A, comma, small letter B, comma, small letter C. Generally, we denote direction ratios of a line by small letter A, comma, small letter B, comma, small letter C. Previously, I told you at the time of concepts, we have discussed this point. That is equal to minus 18, comma, 12, comma, minus 4. Okay, my dear children, understood this step? Right. Therefore, direction cosines of the line, that is equal to L is equal to plus or minus A by root of A square plus B square plus C square, comma, M is equal to plus or minus B by root of A square plus B square plus C square, comma, N is equal to plus or minus C by root of A square plus B square plus C square. Understood this step, my dear children? When the direction ratios of a line are given, to find the direction cosines of the line, we use these 3 points. Okay, my dear children? Right. That is equal to L is equal to plus or minus, what is a value here? Minus 18 by square root of minus 18 whole square plus b 12 whole square plus minus 4 whole square. Understood this step, my children? Right. M is equal to plus or minus b, that is 12 by root of, we write this denominator as it is. Understood this point, my children? Right. Similarly, n is equal to plus or minus, what is this here? Minus 4 by, we write this same denominator here. Okay, my children? Understood this step? Just I substituted the values of a, b and c in these three formulae. Then we got this step. Understood this step, my children? Right. That is equal to, L is equal to plus or minus 18 by square root of 484. By simplifying these three numbers, we get 484. Okay, my children? I wrote directly the value of these three numbers. Okay, my children? Similarly, m is equal to plus or minus 12 by root of 484. N is equal to plus or minus 4 by root of 484. Okay, my children? Understood this step? Right. What is the square root of 484? 22. Yes or no, my children? Right. So L is equal to plus or minus 18 by 22, comma M is equal to plus or minus 12 by 22, and N is equal to plus or minus 4 by 22. Now we strike out numerator and denominator. We divide the numerator and denominator by 2. 2 9 times, 2 11 times. Here 2 6 times, 2 11 times. Here 2 2 times and 2 11 times. Understood this step, and children? Right. Therefore, direction cosines of the line DC is, that is equal to L comma M comma N is equal to plus or minus 9 by 11 comma 6 by 11 comma minus 2 by 11. Understood, my children? Right. Two more questions are there in this exercise, question number 4 and question number 5. Please try yourself the question number 4 and question number 5, my dear children. Will you do yourself, my dear children? Will you try the question number 4 and question number 5, my dear children? If you have any doubts, ask your doubts and get your doubts clarified. Okay, my dear children. Question number 4 is the same as that of question number, example number 5. In the page number 467. In the page number 467, example 5 is there. With the help of example 5, we can solve question number 4. Okay, my children? Will you do the question number 4 and question number 5 yourself? Right.